A very good morning to all the participants. I'm Dr. Swati Gupta, Deputy Secretary, Department of Skill Education, CBSE, and I welcome all the participants who have joined us through YouTube. Enabled to provide inclusiveness, transparency, efficiency, and productivity to the citizens of India, Digital India has come to a Digital India has come out as an excellent means to these ends. For over last 3 decades, geospatial technology has proven to be an effective enabler to meet these challenges. Geospatial course was introduced by CBSE as a skill course around a decade back, and it has continued to introduce learners to the world of GIS, GPS, and so on. As a course, this subject has huge advantage in higher education and job market. One cannot even dream of putting satellites into orbits without having the knowledge of GIS and GPS capacities. This is what this course entails inside itself. So, to understand much better, I'm going to now welcome our expert for the today. That is Dr. Rashi. He is from IIT Kharagpur. He will be our resource person. He has done his PhD from IIT Kharagpur, post-graduation and graduation for Aligarh Muslim University. He has studied remote sensing and GIS during post-graduation and graduation and have used GIS software ArcGIS during his PhD. He has published a number of research papers in the national and international reputed journals. So now I welcome Dr. Rashi to please come and start with the presentation.
Good morning, everyone. Uh, I am Dr. Rasid. As introduced by Swati ma'am, uh, I have completed my PhD from IIT Kharagpur. Now, currently, I am working as a freelance researcher with different professors of international and national universities. One of them is the expert of geospatial technology. In this class, so now we will cover in this class, in this discussion on geospatial technology, which will cover the remote sensing and geographical information system of chapter 3 and 4 of the book Geospatial Technology. Nowadays, as ma'am has introduced, remote sensing and GIS has wider application in the field of urban planning, land use planning, and planning for flooding and droughts, etc. In this class, we will cover remote sensing. In the section of remote sensing, we will have an overview of remote sensing processes flow, and we will learn about fundamentals of remote sensing. We learn about what is the importance of electromagnetic radiation, remote sensing platforms, sensors, and data products. In GIS part, we will learn about the importance of the GIS, what are the components of GIS, and how data is collected and stored and analyzed by the GIS. So friends, let's start with the remote sensing. Remote sensing is a technique, is a method to acquire information about some object or some feature of the Earth's surface without coming into direct contact with that feature. In our body, we have also different types of sensors like ear, eyes. These are the examples of sensors of in human body. Eyes works as remote sensors but it has limitation. We need a plane surface without obstacle. Eyes cannot capture a large area. So, after the development of aircraft, cameras were mounted on the aircraft and aircrafts were used to take to cover the larger area at a time. But these cameras mounted on aircraft has their own limitations, like it works only during daytime in visible light. So satellite sensors were used which capture data both during day and during night time. Now come to the how the remote sensing works. It requires seven elements. Seven steps are applicable in the remote sensing. Remote sensing needs a source of energy which is inbuilt or outbuilt, means solar system. Sun is the ultimate source of energy which radiates energy in the form of electronic magnetic radiation which radiates from the atmosphere where it some of the portion of the light interacts with the particles, gas particles present in the atmosphere, then it reaches the target and it is returned to the sensor, which is recorded and received and processed by the processing station and interpreted and applied for different purposes. When solar radiation passes through the atmosphere before reaching the Earth's surface, any target, it interacts with different gases present in the atmosphere, which causes the solar radiation to scatter, to redirect in different directions, and some of these solar radiations are absorbed by the gases and particulate matters present in the atmosphere, and some of them are scattered by these particles. Then the remaining portion of the solar radiation scattering occurs when particles or large gas molecules are present in the atmosphere. The amount of scattering depends on several factors, including wavelength of the radiation, radiation that is not absorbed or scattered in the atmosphere can reach the radiation that is not absorbed or scattered by the atmosphere reach the Earth's surface, and it is incident upon different features differently. Either it is absorbed by the that object, or it is transmitted from that object, or it is reflected by the that object. The proportion of each of these phenomena depends on the wavelength of the energy, chemical composition and physical composition of that object. Whether some whether incident energy will be absorbed, transmitted or reflected by an object depends on the wavelength of the energy, chemical composition of that object and physical properties of that object. When absorption occurs, what are the absorption occurs when radiation passes absorbed by an object, and when the radiation is passes through any object, it is known as transmission. And when an object bounces back the radiation or redirect the solar radiation into a fixed direction or different directions, then it is reflection. It is the reflected energy which is very important for remote sensing purposes. So onwards, we will learn the properties of the reflected energy. Reflection from any object took place in two types, in two ways, which is termed as a specular reflection and diffused reflection. What is a specular reflection and what is diffused reflection? A specular reflection takes place depends whether an object reflect the energy specularly or diffusely depends on the roughness and smoothness of the feature. If a surface is smooth, then diffused reflection will dominate. And if the surface is rough, then a specular reflection will be dominant. And most of the features on the Earth's surface lies in between these two types of reflection. Lies somewhere between perfectly specular or perfectly diffuse reflectors. Actually, the reflection, as I have told earlier, also depends on the wavelength and frequency of the solar radiation. If the wavelengths are much smaller than the when the wavelengths are much smaller than the surface variation of particle sizes that make up the surface, diffuse reflection will dominate. For example, for example, fine-grained sand will appear smooth in microwave wavelength, but it will appear rough in the visible band. Based on the reflection properties of different objects, we measure the spectral reflectance or spectral signature of different objects, which spectral response or spectral signature for different objects for similar object can be variable uh, depending on the time and the chemical and physical properties of that object. The spectral signature will can be quite variable even for the same target, same object, and can also vary with time. And therefore, it is important where to look spectrally and understand the factors that influence the spectral signature of an object to interpret to get proper information from remote sensing data. So, therefore, the spectral signature, understanding the spectral signature of different objects on the Earth's surface is important to get information, a quality information from the solar radiation remote sensing data. For example, in this graph, reflectance percentage of reflectance is given for vegetation and water, which vary depending on the wavelength of the energy. So, friends, it is important to understand the electromagnetic radiation. as we know that electromagnetic radiation is composed of electrical field and magnetic field. Both of these are inversely related to each other. Electrical field varies in magnitude in a direction perpendicular to the direction of radiation. Particularly, there are two features of electromagnetic radiation which is important to understand the remote sensing process. These are wavelength and frequency of electromagnetic radiation. We have to understand the wavelength and frequency of electromagnetic radiation to properly understand the remote sensing technique. Both of them, wavelength and frequency, are is crucial to understand the information to be extracted from our remote sensing data. Both of them are which are inversely related to each other, means the higher the wavelength, shorter will be the frequency, and shorter the wavelength, higher will be the frequency. So friends, we have to know the electromagnetic radiation as its interaction with different objects, which depends on the frequency and wavelength of the solar radiation. Now friends, we will learn about the different types of platforms used uh, in the remote sensing different types of sensors and data products. In remote sensing, generally,
Dr. Rashid, sorry to interrupt, but the participants are saying that the screen is not clear. Can you kindly enlarge your screen? Put it on a screen share mode.
okay. Is it clear now?
I would request the participants to please put on the chat box whether they are able to see or not. You can start, Dr. Rashid. If it is not clear, I will let you know.
Okay, ma'am. Now we'll know about the remote sensing platforms, sensors, and data products. Remote sensing platforms are of different types. It can be ground-based platforms, airborne platforms, or satellite sensors, satellite-based, space-borne platforms. Ground-based platforms are used when we need a clear picture and accurate information about the surface of the Earth for a smaller area. It covers, it gives data only for a small part of the area. It cannot be used for larger areas. In case of airborne platforms, it provides information for a larger area of the Earth's surface, but it is applicable only during the daytime. We cannot use this platform during the night, as well as there are some other limitations of the airborne platforms like weather conditions and the pictures taken by these cameras are produced in the paper form, which should be scanned. In case of a space-bound platforms, these platforms provide information both for daytime and nighttime, as well as it covers larger area than airborne platforms. This so onwards, we will discuss about the satellite sensors, how it works, what are the how many types of sensors. Remote sensing sensors. Remote sensing sensors are of two types: passive sensors and active sensors. Passive sensors are like the cameras without flash. In this sen- in passive sensors, light the source of light is located outside the sensor. It is dependent on the basically solar light, which limits its use during the daytime. Although the Earth's surface also releases energy. In the active sensors, the source of light is located within the sensor. It is just like a camera with flash, and we can use these sensors to collect information about the Earth's surface features during both day and night time. Now, friends, we will know about the remote sensing data products. The data produced by remote sensing are of two types. These are analog data and digital data. The analog data is captured by the ground or aircraft-based platforms. These pictures, these information are produced as photographs, which is scanned to obtain the needed information using GIS technology. But in case of digital data, it is direct. There is no need to scanning. We can directly transfer it to
Mohammed Rashid, you are not audible.
yeah network.
Okay.
There is a network problem.
Okay. Okay. Please continue.
Yeah, friends, we are discussing about different types of data produced by remote sensing techniques. So, remote sensing technique gives us two types of data. This is one is the analog data, which is captured by the ground and air based platforms, which is these are produced as photographs in the form of photographs, which are scanned and used, analyzed in the GIS software to acquire information, the required information from the that image. In digital data are directly transform transferred to the system or computer from the platform where these data are acquired. Digital data are of two types depending on the source of depending on the technique used for collecting that information. These are digital camera imagery and satellite imagery. Digital camera imagery, these data are captured by the digital camera mounted on ground or air-based platforms. These data are directly transferred to the computers for analysis purpose. Now come to the satellite imagery. These imageries are taken by, as its name is clear from its name, as it is clear from its name that these images are taken by the satellites. The satellites sensors record the EMR, electromagnetic radiation, reflected energy, and convert them into digital numbers. These digital numbers are again processed and converted to by the ground receiving stations into pixels. Then from what is pixels? Pixels are the shortest or the smallest unit that can be captured by a digital camera or sensor. Pixels are the smallest unit of a photograph, which can be captured by the digital camera or sensor. These pixels are arranged into a matrix format to obtain a clear, complete picture or complete information of that a particular location, a particular area, uh, or a particular object. How the digital number of a particular pixel is determined? It is determined. It is determined by the resolution. The resolution determines the digital number of each pixel. It means that better the resolution, better will be the picture. Resolution is the capability of the sensor to collect data about the smallest object on the Earth's surface. But that a smallest object, that a smallest feature should not be smaller than the pixel size. For example, the IRS Indian remote sensing of this version can identify an object of size 72.5 meter on the ground. Because why it is so? Because it has a resolution of about 72.5 meter. As we know, remote sensing nowadays is very important. It is applied for different purposes. The information collected by remote sensing is analyzed using GIS software to obtain information about an area, about a city, and about something, about a river, etc. Now, friends, uh, we will discuss some important aspects about the geographical information system. In short format, it is GIS. So first we start with the fundamentals of GIS. GIS is a software which is which is used to analyze, to organize the spatial as well as non-spatial data. We can obtain information about different features of the Earth's surface.
Dr. Rashid, your presentation is not moving.
Okay, ma'am. Actually, I am facing the network issue in the laptop.
Okay.
In GIS, we are discussing about the importance of GIS, why GIS, what is GIS. So, friends, GIS is a software which is used to collect, to get information, to get data about the spatial and non-spatial objects or features. What is the spatial information? Spatial information means any information having a georeference. It is it may be about geographical distribution of any land use, land cover, population distribution of different types of crops, communication and network connectivity features. And in case of non-spatial data, non-spatial data is the characteristics about a particular location or a particular feature like a city or town, a state, different characteristics of land use properties, whether it is used for cereal crops or commercial crops or plantation crops. For all these information we can take from the geographical information system. GIS are nowadays used to make dynamic map, to display information in detail about some features. GIS builds some a spatial relationship between different features and analyzes and answers. We can analyze and answer the real world problem which we are facing in a real actual world. We can answer this question easily using GIS. There are the GIS uses some GIS software is based on some components which is essential to get a good information from the GIS. These are known as the components of GIS. There are five components of GIS, which all of them are important to get a good information from GIS software. These are the hardware, which is in the form of computer, software like GIS software, and we need people to uh, acquire data, to analyze data, and to represent data in different forms. So, friends, data is the most important part of the GIS technique. In GIS, data is acquired from different sources. It may be field data, it may be satellite data, analog maps, reports, etc. We acquire data from these sources and store them into the GIS database. We can change or reclassify or change the scale of this data using in the GIS. In geographical information system, we use different models, statistical techniques, and digitization process to analyze the acquired data. After analysis is complete, it is displayed in the form of GIS displays this data in the form of images, graphs, maps, etc. Now we will learn about how to create digital spatial data into GIS. There are four techniques of storing data into the GIS software. It may be in form of X and Y coordinate. When we have some data which are in the form of X and Y coordinates, then we store data in the form of X and Y coordinates like this. Another way of including data in GIS is the database entry through the keyboard. It is basically used when we have information related to some attribute of a particular location like census. Another method to include data into the GIS is the digitization. In digitization, we convert the paper map or digital map. We digitize different areas, location, and lines like transportation lines, rivers, and district boundaries, etc. using the digitization. We can include information related to our area like a state or district or city by digitizing that area and connecting data of particular area to that digitized map. Another way of including data into the GIS software is the scanning. Through the process of scanning, when we use this scanner, when we have data or map in the paper form, then we need to scan these maps and include it, store it in GIS software. There are several methods of data storage in basically data. GIS stores spatial and non-spatial data as I have discussed earlier. GIS stores spatial data in two formats. It may be in form of raster format or vector format. In raster format, data is stored in terms of grid of cells, which has a specific value to the associated object, associated as related feature of that particular cell. In case of raster format, in case of vector, sorry, in case of vector format, data features are stored in terms of point, line, and polygon with reference to coordinates, latitude and longitude of a particular location. Points, where we do use points, points are used to represent, to locate, to indicate the location of any city, village, or important locality or some other locations on a map, such as these are also used to indicate the location of schools in a particular area, number of schools in a district, number of houses in a district or area. The lines are used to represent the linear features. The lines are used to represent data which are in terms of linear data. It may be like rivers, roads, railway networks, and state boundaries, district boundaries, etc. are represented by the lines. Another way of storing data is the polygon. Polygons polygons are used to represent a, an object which has some spatial or area, like city, soil type, or land use type, an area of a district, an area of the state. So these three features we have need to understand before using the GIS, before going to the practical class. After this, we need to know about all these three features, as in GIS nowadays we use mostly vector format. So understanding these features are important during the practical to understand the GIS software, to use the GIS software properly. So these are the three important features through which we can represent or get information on a map about different locations or different spaces. These points, I will repeat again. So points are used to represent the number or location of a particular feature. Like if we want to locate number of hospitals in an area or location of hospitals in an area, then we will use point. If we want to locate some important roads passing through on the important location, then we will use line. And if we want to cover that from where the patients are coming to that hospital, then we have to use the polygons.
All right, Dr. Rashid, I think we can take 2 minutes break, and there are many questions on the YouTube chat box because I think the participants are here for the first time, but this training is specifically arranged for the teachers teaching geospatial, so they have a certain level of knowledge when it comes to geospatial, and it is also for those teachers who feel like taking up this course in the future. So this is just an introductory course. I would suggest the teachers to be a little patient and let the participant, let the expert go with these slides, and after that we are going to have a practical session. So this is just an introduction of what is going to be taught and in practical session, which will commence in another maybe 20-25 minutes. So and also I would request all the participants to please put up your queries on the chat box so that that can be placed to the expert. And as far as attendance is concerned, you will get your attendance link on this very YouTube site. I will paste it and you can fill it up. And thereafter, you will get your assessment links. So, teachers, I'm sure for those who are learning it for the first time, you must be finding it very difficult to understand or little new. But over the time, when the practicals will be conducted, you will understand what geospatial technology is all about, and you will really like the subject, so that you can also teach it to your students. So, if there are any questions, please put up on the chat box. There is a lag of at least 2 minutes, so let the professor start with the continue with the presentation. I'll take up your questions a little later. Thank you, Dr. Rashid. Please continue.
Okay, ma'am. In GIS, we we can use analyze data using different techniques and methods. We can use different colors to represent different uh, spatial distribution of different crops or population density using different colors of for that area, or we can use pie diagrams on the map or bar diagrams to show distribution of some crops or population density, etc. For geological features, we can use contours for that area, and we can represent data for watershed using different colors, lines, contours, etc. Now we will discuss about different techniques used in the remote sensing, GIS software for different purposes. We use buffer GIS by expanding the by creating the new polygons or in there is another known as map generalization. In map generalization is applied the unnecessary data to free up the space into the from the software or to store new data files. So we will learn about these things in the practical class. Map generalization is important to clear some space by removing the data files which is not required, which is not important for analyzing or for getting information for a particular space or a location. We use digital terrain analysis to acquire information, to collect information by for the height and depth or slopes of a particular area. This analysis permits us to interpret the point data, derive the slopes of that area, watershed computations, and construction of different sets using different sets. We use then we use network analysis. It is very important during particularly during the time of emergency. In the network analysis, we use we define the optimal path of routing of to predict the points to reach our destination through the in a shortest time, which is particularly important during the time of flooding to uh, send the resources to needy person during the earthquake and other calamities. So during we use this network analysis to predict the best route, which would be the uh, best route to deliver the to reach the point of calamity or the shortest route which will be the shortest route to reach that particular point in a shortest time.
Dr. Rashid, your voice is not audible.
Okay, ma'am. Is it clear now?
Yes, it is clear now.
So I was discussing about the importance of network analysis and
Dr.
when we
Rashid, sorry to interrupt, but there are a lot of questions coming on the chat box. I think we can take the questions. Dr. Rashid, am I audible? Dr. Rashid,
yeah, ma'am.
let me take few of the participants' questions. First question is, what is buffer? Are you getting my voice? Dr. Rashid?
Yes, ma'am.
Yeah, the first question is, what is buffer? Are you having some network issues?
Yes, ma'am.
Okay, then I think you continue with your presentation and then we can take the questions. Please continue with your presentation. Dr. Rashid, are you there? You're not audible.
Yes, hello. Am I audible?
Yes, Dr. Rashid, you're audible. Please come online. Please continue with your presentation. We can take questions later.
Okay, ma'am. I was discussing about some techniques of the data analysis in geographical information system and digital terrain analysis. We analyze the height and depth of a particular area. It gives information about the watershed, slopes. So we use which is represented on the map using different shades. There is another data analysis technique called network analysis. In this analysis, we route the resources along a set of linked linear features. We identify the optimal route or optimal path to reach a particular point in a shortest time, so that this type of analysis is particularly important during the emergency time like flood, earthquake, etc. These are some of the data analysis techniques which are used in the GIS. Now I have finished my the theory part, so I am ready to take questions and I'll respond to your queries.
Sure, Dr. Rashid, and sorry to interrupt you in between. Now we can take up the questions. The very first question is, what is buffer?
Ma'am, buffer is an area which has a specified distance.
Okay. So how do you buffer? Technique? Is there a technique for buffering?
We use a point, line, or polygon to buffer an area.
Okay. So other than Rolta Geomatica, is there any other software available for GIS?
Yeah, QGIS. It is a open software.
Okay. QGIS is an open software that can be used as per our
Yeah,
experiment.
anyone anyone
Great.
can download it.
Am I audible, Dr. Rashid? Am I audible?
Yeah,
Okay, I'm so sorry. I just got logged off. I'm taking up the next question. Is there a GIS software available on the mobile? Dr. Rashid, the next question is, it seems that there is a network issue on your side. I think we can take a 10 minutes break and then come back for the practicals. I request all the participants that I will take up your questions for the practical session, and we can meet around it's 11:34 right now. We'll meet around 11:44. So please don't log out from this session, and then I can post the attendance link as well. So we'll meet in 10 minutes. Hello, Mom, Dr. Rashid. Good afternoon, everyone, and welcome back to the second half of the training. This time, the training shall have a practical demonstration of QGIS. All the practical aspects will be demonstrated on QGIS. So now I request Dr. Rashid to please share his screen.
Okay, ma'am.
As Dr. Rashid has already mentioned, QGIS is an open software. So that software is being used for the practical demonstration for this training purpose.
Yeah. Hello, everyone. Now we will learn about the georeferencing and digitization of polygons, area, line, and points using QGIS. So, friends, this is the QGIS software. Here, first, I will show you how to georeference a map. I will you I will show you two different methods for georeferencing a map. If a map, when the coordinates are given on a map, coordinates means latitudes and longitudes are given on a map, then how we will digitize that map? And when the latitudes and longitudes are not indicated in a map, then how will we will georeference that map? First, we will go to raster, click on raster. Here we click on georeferencer. A new window will open. Go to the open raster and click on the folder where you have saved that map for georeferencing map. For georeferencing, in this georeferencing, I will use a map district map of Delhi. A new dialog box will open after clicking on the map. Here you can type, you can select any projection of your choice, like you may select polyconic, or you may select UTM. You may search from filter any type of projection system. In this case, I will use WGS84. Click on OK. In this map, the coordinates are indicated. Now go to the transformation setting. In transformation type, you may select any one. A number of choices are given in the transformation type. It may be linear, polynomial 1, polynomial 2. In our case, I will select linear as given in the default. In the resampling method, again a number of choices are there. As per your requirement, you may click on nearest neighbor, linear, cubic, etc. In this case, I will use nearest neighbor. We have already selected the projection system. If we want to change or use at this stage another projection system, then click on this icon and again search for the uh, projection we want to use in the filter. In this case, I will use WGS84. Click on OK. Now come to the output raster. We have to save this map before georeferencing. To click on this icon and give some name to, as it has given here, delete 28 modified form. Click on save. Now click on OK. And select add point. A minimum of 4 points should be selected for the georeferencing, but it will, if we want a better result, we will select more than 4 points, like 6 points, 9 points. So our georeferencing will be better. I am click on the first point. Then a dialog box will open, like where it is asked to put the values of longitude and latitude. In the x or east, we will write the value of longitude for that particular point. Here it is 77 . In latitude, it is 26 degree and 80 minutes. Click OK. Again, we will click on the another point.
Dr. Rashid, nothing is visible. If you are doing something, then it's not visible.
Okay. I have to share this screen. Now is it visible?
Yes, the map is visible.
The screen is not visible.
Now the pane is not visible.
Pen is visible or not?
Yes, now both are visible. Yes.
Okay, I will start again. I will repeat. Go to raster and click on it, then select georeferencer. A new window will open. Is it visible? New window.
Yes, it is visible.
Uh, Now go to the left corner, open raster. It will take us to the a folder where we have saved our map. Select a map which we want to georeference and open it. Then another dialog box will open where we have to select projection system for a particular map. Here we can select any type of projection as per our choice, like we can use polyconic or UTM. Means we can select of our choice, but in this case I am selecting WGS84, World Geodetic System. Click on OK. Now our map is visible in the window. Now we will go to add point and add at least a minimum of 4 points for georeferencing the map. But if we add more than 4 points, it gives a better result. In this case, I will choose 6 points. We will select a point where the longitudes and latitudes are intersecting each other. As we click at a particular point, a dialog box will open. It indicates about the longitude and latitude. We will put the value of longitude in the x or east. In y or north, we will put the value of latitude. We will select another point. Click OK. Likewise, we'll select diverse points so the result will be better. Now I have selected 6 points. Now we will go to start georeferencing. Just click on it. Our map is now ready to georeferenced. We can see this. Now close this window. In another case, when the latitudes and longitudes are not given on the map, then how we will digitize that map? First, in this window, we will open a raster layer, which is already georeferenced. Click on open. And go to raster. Click on georeferencer. A new window will open. Select here open raster and open a map when where the latitudes and longitudes are not indicated. Again, same dialog box will open. Here you have to select the projection system of your choice. You may choose any of the projection by typing the name of projection here, like a polyconic, or any other projection of choice. In this case, I am selecting World Geodetic System 84. Then you can see that latitudes and longitudes are not given in this map. Then how we will georeference this map? We have to select a certain location which is easily traceable in other map. Through we can georeference this map with the help of other map which is already georeferenced. Click at a particular point. The dialog box will open which demands for longitudes and latitudes. In this case, as the value of latitudes and longitudes are not given, so we will go to from map canvas. Click on this button. It will take us to another map which is georeferenced. Click on the same point as I have clicked In the previous map, click on the the value of longitudes and latitudes will be automatically taken, automatically filled. Click on OK. Likewise, we will select 6 points at different corners of the map as it gives good result. Now another point, click OK. Go to my click OK. Any point from the map you can take, which is easily traceable on the another map. We have selected 5 points. Now I will select the last point. So now we have completed all 6 points. Now go to the start georeferencing. Our map is now georeferenced. Close this window. We now I will show you how we use different digitization. How we digitize the map using different points, polygons, and lines. So click on New, open a georeferenced map here. We can check the map is whether georeferenced or not by putting our cursor on the map and looking into the coordinate pane, which is given in the lower part of the window. If it is georeferenced, then the latitudes, longitudes will appear correctly. If it is not georeferenced, then it will not appear correctly. Now go to the layer. We'll select, go to create layer and select a new save file layer. A new dialog box will open, which will demand, here you can select point, line or polygon. First, I will select polygon, put some name here, like I am going to digitize districts. So I will give it a name district. Click on add to fields. Click OK. Give some file name to it. Click on save. Now click on district and then click on toggle editing. As we click on toggle editing, all features like add feature, add circle string, all features become active. So we will select add feature, zoom the map as per your convenience. In this class, I will digitize three districts of Delhi as a number of features are located here. So we can use different points and polygon. So we can learn the use of points and polygons and lines. If some point we want to delete some point, if something goes wrong, then click on delete button on the keyboard. We will go to the previous point. After finishing the digitization, just right click on the mouse. Another dialog box will open. Here you give an ID, one, and give a name like the district name. Click on OK. If you want to check the our digitization is correct or not, just select node tool and click on the node and zoom it to see whether some correction is required. We can click on a point and drag it to our location. Any point like this, when we can correct the mistakes. Now click on save. Now we will digitize another district. After coming to this point where we have to join two districts boundary, it is it is important to put on the sniping option. Without this, we cannot clearly, accurately match the boundaries of two districts. So go to setting. Here is our sniping option. Click on vertex and segment. Give a value 0.5. Click on OK. It will automatically attract the cursor to the point where overlapping of two districts boundary are taking place. You can click, you can see that it attracts the cursor automatically. Click on these points. After finishing, click on right click on the mouse, give a ID to give a name to the district. Click OK. Again, we can create digitized lines using the node tool. Click on any point. Now click on save. Now I will digitize another district. Put on snapping tool, go to snapping option, right click on mouse, put an ID value 3, this is district New Delhi, click OK. Now click on node tool, now click on this if you want to correct something. First off, put off the snapping option. Click on save. Now we have digitized 3 districts of Delhi. To remove this cross, click on toggle editing. It will automatically disappear. Now right click on the district and go to properties. From here we can change the color of shading. We may choose any color. Click on apply. The color will automatically change. If we want a number of colors, then select here I have selected single symbol, so all districts are appearing in the same color. At this place, we'll use the categorized. As we use categorized, then click on classify, then click on column and add district ID or district here. Then click on classify and after that click on apply and the district the colors will of the digital districts will automatically change. Here you can see the change of the color. Go to label. If you we want to add the label in at the place of no label, we will add show labels for this layer, and again in label with will label with the district name. Here we can change the size, font size. We make we may make bold or italic or anything bold italic from this option. By clicking on this option, we increase the font size of the label from here. Click on apply and there are other options which we can use from here. If we want placement, change in placement, we can change the placements from here. Click on OK. So we have digitized 3 districts of Delhi, New Delhi, South and Southeast. Now we will learn to add other layers like line and location point. Go to the layer, click on layer, create layer and select new shape file layer. A dialog box will appear and select line. Give some name like if based on the line we are going to digitize. First we digitize the state boundary. So we will write the state boundary. Its length is fixed, so it takes only this much of letters. Click on add to field list, then click OK. Give some name. Click on save. Now click on state boundary and select toggle editing and click on add feature. Zoom the map. After finishing the digitization, right click on the mouse, put some ID and name here, click OK. If you want to make corrections in the line, then click on Node tool and click on the line. We can, in this way, we can make corrections if we have made some mistake in during digitization. Now save it and close the toggle editing. Now go to properties, click on style. You may change the color of a state boundary. I will select black. We can change the line style. At the place of solid line, we will use dash that dot line on any other line like we will use dash line. Click on apply. We can increase the width uh, of the line by increasing the pen width. Apply. Okay. Now we'll add district line. Go to layer, create layer and select new shapefile layer. Click on line, give some name. Here I will give district name, district. Click OK. Click on toggle editing, then select add feature. Click at a point of a map.
हेलो राशि सर। हेलो
Yes, sir.
सर, आपकी आवाज नहीं आ पा रही लाइव पे। सुन पा रहे हैं सर?
Yes, sir.
सर एक बार आप चेक।
I audible?
ओके सर। हेलो राशि सर।
Yeah.
सर प्रेजेंटेशन शो नहीं हो रही सर आपकी।
थोड़ा नेटवर्क का इशू हो गया, मैं ट्राई कर रहा हूँ।
ओके सर।
After finishing the district line, click right click on the mouse, give some ID, one, click OK. If some changes are required in the line, then click on Node tool and put your cursor on the map and click on the line. From here we can correct the line. Click on save. After finishing the line, right click on the mouse, give it ID number 3, click OK, click on save, go to the right click on district 2, go to properties, we can change the color of line from here. We'll select black, apply, select on simple line. At the place of solid line, we can select any of line, dash line. I will use dash line. We can increase the thickness of the line from here. Click apply. Click OK. Now I will show you how to digitize a transportation link, a transportation network or river. Go to layer, create layer and select new shape file layer. Here we will select line. Right here national highway or whatever the road it will be. Click on add to field. Click OK. Click save. Click toggle editing, then select add feature and start digitizing. After finishing the line, right click on the mouse, give a ID, You can put road name, click OK. Now start digitizing another line, another road. Click OK. Save. Click on save. Click on toggle editing. Right click on the roads. Go to properties. From here we can change the color and width of the line. Click apply, then OK. Now you will digitize the river passing through the district. Go to layer, select new shape file layer, select line, give a name, add to field list, click OK. Click on river, click on toggle editing, select add feature, After finishing the live, right click on the mouse, give an ID. You may put the river name here. Click OK. Click on save. Then close the toggle editing. Right click on the river. Go to properties. From here, we can change the line. Change its color. You may select from here if river is given. Click apply. Click OK. Now we will trace some important locations in the district. First, I am going to select airport. Go to create layer. Select new shape file. Click on point. Give some name. Click on add to field. Click OK. Select toggle editing. Click on add feature.
Dr. Rashid, you are not audible.
Yes. Okay. Actually, we will put a ID. Click OK. Click on save. Am I audible now?
Yes, yes, you are audible.
Go to airport. Right click on it. Go to properties. We can change simple marker to any other marker which one you want to use. We will use. In this case, I am showing the airport. Increase the size of the marker from here. Click apply. Then click on OK. The symbol is now changed here. Now we will locate some important localities located in these districts. So again, we will go to the layer, create layer, and new shape file. Select point, add some name here. Click on add to fields. Click OK. Click on toggle editing. Select add feature. Now type the name of the locality. Click OK. Click OK. Click OK. Click on save button. Then toggle editing. Right click on the locality. Go to properties. Go to style. and you can change the color of the marker from here. You may select any color. You may increase the size of marker from here. You may change the shape of marker. Go to labels. At the place of no labels, we will click on show labels. Now come to label width. Add your locality name. Click on apply. We can change the location of the name of locality by clicking on this. Click on apply. We also change the font size of the text by clicking on text. You may make it bold. You may increase the size, font size. Click OK. So friends, we have learned how to trace polygons, lines and points on a map. If we want to put number on the highway, then we have to select point and we will click on the point. Make another layer, go to create layer, select new shape file, select point, click here on road number, click on add to field list, click OK, give a name here, click on save. Click OK. Click OK. Now right click on the road number, go to properties, go to style, change the color, change the shape, increase the size of shape, Go to labels, click on apply. Okay. We want to increase, we have to increase the font size of the road numbers. Then again go to the road number, click, right click on select properties, make it bold from here, increase the font size. We may change the placement. Click OK. Now we have traced all objects on the map like polygons, roads, rivers, and some important locations. Now we will learn how to export this map in a PDF format or JPEG or TIFF or other format, and how to put the coordinates. Click on this layer to hide the raster layer. Our new map for 3 districts of Delhi is now ready. Now we will learn to export this map as in the form of PDF or JPEG in a picture form, image form. Go to project, click on project properties. A dialog box will open. Select on, click OK. Again go to the project, click on new print composer, give some name, click OK. Another window will open. Go to composition and we can change the page size from here. Select A3 size, select, select move item, Click on Add New Map and put your cursor in a corner and drag it to another corner. The map will automatically appear on this. If you want to change the position of map, then go to Move Item Content. You may drag the map here and there. You may make the map large or smaller. Add if you want to add some title, go to Add New Label and make a box here. Go to Item Properties. Just select this item and write the name of title of the map. It may be the district. Districts of Delhi. You can change the font size from here, make it bold, make it larger, click OK. You may change the placement of the title by clicking on the horizontal alignment and vertical alignment, making it middle. You can change the color of title from here. You can frame the title by clicking on the frame. Now we will add another important feature of the map, that is a scale. Go to Add New Scale Bar and click on it. Just make a box here. If you want to change the style of the scale, go to the style and click on it. There are a number of options. You may select single box, double box, line text in middle, etc. I will select double box. You may increase or decrease the segments of the scale. We can change the font size and color of the font. Click OK.
You're not audible, Rashid. Dr. Rashid, you're not audible.
Hello? Yes, ma'am. Am
Yes,
I audible now?
yes, you're audible.
Add legends to the map. A number of items which are not required also appear in the legend. So we can update the legend by clicking on auto update and remove some item from here by clicking on minus. We can change the name of the legend by double clicking on it. Now our map is ready. We can export it as PDF or image form. Here I will show. Here I will export this map in an image form. Just click on this icon. If you want to indicate the grids, then click on grids, draw grids. Click on draw coordinate. Now close this window. We have made the map. Our map is ready. This is the map we have made in this class. Close this window. Thank you. Thank you, everyone. I have finished my class, ma'am.
Thank you, Dr. Rashid. It was indeed a very learning experience for all of us. Next time, I would request all of you to please practice it on QGIS. As Dr. Rashid has mentioned, it is an open software. So you can practice a map and then do it. Tomorrow again we will have a practice session. So if all of you have a device where you can, practice along with Dr. Rashid, then I think you would be able to understand it better. So Dr. Rashid, how can we get QGIS? Dr. Rashid?
Go to Google and type the QGIS software. You will.
Okay. So this way you all can download QGIS on your computers, and tomorrow you can practice it with Sir, so that it becomes more of an interactive session, and you can also learn while you are seeing and practicing and watching it on the YouTube. The session now stands closed. We will be sending assessment links to the registered candidates. I must really reiterate now that the session training is for the teachers teaching GIS, geotechnology, in the CBSE affiliated schools. So we are certifying those teachers who are teaching this course. However, those teachers who are part of this session, out of curiosity or out of understanding this course, you are most welcome to continue with us tomorrow, as we will be teaching more on the class 12th curriculum. So with this, I am signing off, and we shall meet tomorrow at 10:15. Thank you so much.